This is Elizabeth Pluswick, and continuing on the previous example from the FE Engineering Economics Problem Resource, we just looked at example 1520, incremental analysis, when we were trying to find the rate of return between the two options and the rate of return on the incremental cash flows. That's one strategy that's the strategy we just went over that you use when you're asked to find the rate of return. You can do the same kind of analysis, same exact situation, but the benefit cost analysis, I'll take you through that. Benefit cost analysis is just a BC ratio. We want the present value of the benefits to be greater than the present value of the costs. Stated another way, the average annual benefit, EUAC, should be greater than the equivalent uniform annual cost. They're both considered considered benefit cost analysis. You always want the benefits to be greater than the costs, whether those benefits are stated in present value terms or annuity terms, right? The benefits always need to be greater than the cost for it to be an acceptable project. So it'll give you the same answer as rate of return analysis, just a slightly, a little different analysis, but it'll come out with the same answer, alternate A or alternate B. You're going to get the same recommendation. It's just another way to analyze the cash flows. So again, we take our two alternates, find the increment or difference by taking the higher cost minus the lower cost, and come up with this difference or increment column. And then we do the analysis only on this third column. Present value of the benefits divided by present value of the cost. So the benefits are an annuity of 29.5 for 3 years. So find P given A, 10%, 3 years. Multiply that factor times 1 year's annuity amount, 29.5, and divide it by the present worth of the cost. The cost of this equipment, again, just taking the increment column, the difference in cost is $69. That's happening at time 0, so it already is in present day terms. So just the 69, no factor is needed. So find the factor from that table, multiply it by 29.5, and you'll get 73.37. Divide by initial cost difference of 69, and the answer is 1.06. Now what does that mean? That is a ratio. That's not an interest rate. That's not a payback. It's a ratio of the benefits to the costs. The decision rule is we want that ratio to be greater than or equal to 1. This ratio is greater than 1, so this incremental cash flows are acceptable. We want them. And these incremental cash flows are only available, they only come in this higher cost alternate. So again, alternate A, from benefit cost analysis, alternate A is the more financially beneficial option to solve this problem. Between A and B, A is more financially feasible, gives a higher payout, as shown on present value benefit cost analysis.